Hello and welcome. Today we're going to be looking at probability and combinatorics. This is one of the topics in Precalculus. As always, we're going to be going through all of these questions this entire unit test to help you understand how to approach and solve these questions. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question of this unit. Here we go. Airlines are usually willing to overbook flights and sell a few more tickets than they have seats available. On most flights, some people who buy tickets don't show up, so everyone who does show up gets a seat. But if too many people show up, the airline must move some passengers to another flight and give them a large credit. An airline tracked how many passengers needed to be moved off a certain flight in each of the last 500 times the flight ran. Alright, so we're given a number that are moved off flight 0, 1, 2, 3. Frequency 290, 160, 30, and 20. Okay. Based on these results, which graph represents an approximate probability distribution of the number of passengers move off this flight on a random day? Okay. So let's think about what we could do with this, right? So let's get out a calculator. All right, pull out your calculator. Calculator. Right, I had it off to the side. So let's pull out our calculator. We had 500 times, and for 0, that's 290 out of 500, or 0.58, so more than half. So you see for B, that looks like more than half. C doesn't, and neither does A. So B looks like it's correct. Let's check everything else though. So 160 for the next one. For 1, it's about a third, 0.3, yeah. For 2, 30 out of 50 is going to be, 30 out of 500, sorry. It's going to be 0.06. Right, so you get that around 0.1, and then 3 is even less. And that's our answer. Let's keep going. Tom and Rosie are designing a game. In each turn, a player rolls 5 six-sided die and adds the number showing on each face to determine how many points that they get that turn. For example, the lowest number of points in a given turn is 5. 1 plus 1 plus 1 plus 1 plus 1. The highest is 6 plus 6 plus 6 plus 6 plus 6, or 30 points. They let x represent the sum in a given turn and find the expected value of x is e of x is 17.5 points. Tom says a player will most likely get 17.5 points in any given roll. Rosie says over 100 turns we can expect a total of around 175 points. Well, let's see. So Tom says in any given roll, it's most likely that they get 17.5 points. Well, let's just think about what that statement means for a second. Let's just think about that with common sense and intuition. There's 17.5 points. How am I supposed to get them number? How am I supposed to get a half a point? What? How am I that doesn't work, does it? But you can't get a half a point in a roll. All right, maybe he's trying to say that on average you get that many points, which would be correct, but that's not what he's saying. His statement that you get 17.5 points, which is impossible. So that's not true. So Tom's statement is incorrect. Then Rosie says over 100 turns we can expect a total of around 175 points. Well, we have 17.5 points per turn, so over 100 turns, right? 17.5 times 100 is 1,750. That's not 175, that's a lot different, right? So neither of these statements are correct, and our answer is D. Let's keep going. Tariq and Lucia are finalists in a baking competition. For the final round, each of them will randomly select a card without replacement that will reveal what their primary flavor must be. Here are the available cards. So we have chocolate, vanilla, lemon, raspberry, strawberry, coffee. Tariq wants to get lemon, and Lucia wants to get coffee. Tariq will draw first, followed by Lucia. What is the probability that both contestants get the ingredient they want? So how many different possibilities are there? So Tariq has 6 possibilities, right? Six options, and then Lucia has 5 options based on that. So we have 30 options total, and we don't have to divide by anything since there are no repeats, right? It's not like Lucia draws first and then Tariq. It doesn't matter, right? Because Tariq, we know that he goes first. So 30 options, and there's only one that both contestants get the ingredient they want. Tariq gets lemon, and then Lucia draws coffee. One option out of 30 total. That is going to be 0.03. That's our probability. Let's keep going. All right, a salon owner noted what types of services its clients requested last week. Here are the results. So you have dye haircut, permanent, and a big Venn diagram. In the sample are the events die and permanent mutually exclusive. So what does mutually exclusive mean? It means that there's nothing that belongs to both of them, right? So let's see, is there anything, there's no overlap between die and permanent, meaning that nobody got both, right? Nobody got both a die and a permanent. So they are mutually exclusive because there's nobody who got both. So they are mutually exclusive. Find the probability that a randomly selected person from the sample requested a die or a permanent. So we have 35% in here, in this circle right here, 35% who got a die. And then here we got 15% who got a permanent. So that's 50% or one half. One half. And we can move on to the next question. A standard deck of cards has 52 total cards divided evenly into four suits. 13 clubs, 13 diamonds, 13 hearts, and 13 spades. Clubs and spades are black cards, while diamonds and hearts are red cards. Marquis and Sasha are playing a game that involves drawing two cards from a standard deck without replacement to start the game. If both cards are the same color, then Marquis goes first. Otherwise, Sasha goes first. Is this a fair way to decide who goes first? Why or why not? Let's see. So, drawing two cards from a standard deck without replacement, you have 52 times 51 ways to do that. Right? 52 times 51. And well, we could divide that by 2 because for each option, right, you're repeating it twice, right? So you could say you drew like I don't know, like 3 of clubs and then a 5 of clubs, which is the same as drawing a 5 of clubs and then a 3 of clubs. But you don't really need to. You can just leave it. That's the number. If we do count the repeats, right? Now, the main thing about this, about like canceling out, is that you have to be consistent. All right, it really doesn't matter what kind of system you use as long as you're consistent with everything. If you do the same thing with everything, then you'll be fine. You just can't switch it, and it becomes really, really simple and really common if you kind of switch it around, and that's not what you do. So just make sure you don't do that. So for doing this, we're not going to count any repeats at all. Now, if we think about both cards are the same color, well, 26 options, right? 26 of the first color times 25 of that color again, and that could be for both red or black, so we multiply that by 2, and we get 1,300 options. Then Marquis goes first. So 1,300, so this is my calculator. Okay, so you have 1,300 options where Marquis goes first out of the 2652 options, meaning that Sasha goes first 1,352 times. So she goes first more times than Marquis goes first. So there's a higher probability that Sasha goes first, and the game is not fair. It's not a fair way. Let's keep going. An insurance company offers renter's insurance to customers in a certain area. Suppose they charge $40 for a given plan. Based on historical data, there is a 1 in 500 probability that a customer with this plan makes a claim, and in those cases, the average payout from the insurance company to the customer was $5,000. Here's a table that summarizes the possible outcomes from the company's perspective. So, what do we have? What is there to do? Let's see. So, event and payout and net gain X. So claim $5,000, net gain negative 4,960. No claim is $0 and net gain is $40. Okay, let's see. X represent the company's net gain from one of these plans. Well, let's see. So essentially, you're charging $40 for a given plan, and you have 500. If you had 500 cases, right? If you had 500 cases, then you get 500 times that $40, so $20,000. Now that in those 500 cases, there'd be one claim, and that would be $5,000. So you subtract $5,000 because that's how much they had to pay out. So now they have $15,000 in profit, right, in net gain. That's for 500 cases. So we divide by 500. Each case has $30 of profit, right? $30 of profit. Let's keep going. All right. Micah is one of 28 students in a class. Micah's teacher is going to randomly select 3 students from their class to visit a classroom of younger students. What is the probability that Micah is included in the group of students chosen? Okay, so how do we go about doing this? What do we think about here? Well, let's see. So if so how many ways are there to choose 3 students from 28 kids. From right, that would be 28 choose 3, which you can write as 28 big C 3. That's the denominator because that's the number of possible options. Now, if Micah is included, that means that you now have 2 spots left to fill out of 27 students, or 27 big C2. So 27 big C2 over 28 big C3. All right, 27 choose 2 over 28 choose 3. That's the probability that Micah is included. So that is our answer. Let's keep going. Hugo plans to buy packs of baseball cards until he gets the card of his favorite player, but he only has enough money to buy at most 4 packs. So that each pack has probability 0.2 of containing the card that Hugo is hoping for. Let the random variable x be the number of packs of cards Hugo buys. Here's the probability of for x. What's the probability that Hugo buys at most 3 packs of cards? Okay. So if at most 3 packs of cards, that's the probability of 0.2 plus 0.16 plus 0.128. Okay, so we just add those up and we get 0.488. 0.488. And that is the probability that he buys at most 3 packs of cards. Anything 3 or less. Let's keep going. Kelsey works at a bicycle shop as a salesperson. She records the number of bicycles she sells on a daily basis. Here's the probability distribution of B equals the number of bicycles Kelsey sells on a randomly selected day, and T equals the time she spends filling out daily sales reports. B equals number of bicycles sold, 0, 1, 2, 3. T equals time in minutes, 0, 10, 20, 30. Probability is 0.3, 0.5, 0.15, and 0.05. Find the expected value of the amount of time Kelsey spends filling out daily sales reports. Okay, let's see. So, how do we do this? All right, how do we do this? Okay, so the probability of having no bicycles sold is going to be 0.3, right? And it's going to take 0 minutes, obviously. Probability of having 1 bicycle sold is going to be 10 minutes. Is going to be 0.5. That's going to take 10 minutes. That's going to be around 5 minutes. And so on average, it's going to be 5 minutes. Plus 0.15 for 20 minutes for 2, so 0.15 times 20 is going to be 3 minutes. And then 0.05 for 30, right? 0.05 for 30 is going to be 1.5 minutes. So in all, it's going to be 9.5 minutes. Not a bad amount, honestly. And that is that. A board game uses a spinner like one below, where 0, 1, 2, and 3 are all equally likely. Each turn, a player spins twice and adds the results of the spins. Which graph represents the theoretical probability distribution of the sum on a given turn? Well, the lowest is going to be 0, the highest is going to be 6. So we can go from 0 to 6. I don't know why they have a 7 here. That's not possible. And here it only goes up to 3, so this one has to be correct. Right? As you see, you have 0, which has 1/16th chance, 1/4 and 1/4. Same with the 6. The 5 has 2 ways to do it. The 5 and 1 have both 2 ways to do it. 2 and 4 have 2 ways each, 3 ways each, and then 3 has 4 different ways to do it. And that's a probability distribution. Let's move on. Elizabeth has a collection of liked songs on her phone. She has her phone set to play one of these songs as her alarm every morning. Here's a summary of the genres of the songs. So you have rap, rock, alternative, and other. Right? 240, 80, 60, 20. Right? Which graph correctly displays the probability distribution for the genre of a song on a given morning. So 400 total, 240 are rap. That's going to be 6/10, so 0.6. So 0.6 is rap, right? So these two do it. For rock, you have 80 of 400 is 0.2. So 0.2 is rock. That's this one. Alternative is 60 out of 400, which is going to be, say, it's 3 out of 20, so it's about 0.15 in the middle, right? That's what that is. And then the other is just going to be that extra 20, extra 0.05 right here. So that's our answer. And let's move on. A standard deck of 52 cards has 13 clubs, 13 diamonds, 13 hearts, and 13 spades. Suppose that Ramon is going to draw 2 cards without replacement. Here are some events and their meanings. Event D1, D2, D1C, D2C. So the first card is a diamond, second card is a diamond, first card is not a diamond, second card is not a diamond. So probability that D1C and D2C equals PD1C times PD2C if D1C. Oh god. So PD1C and TD2C means that both of them are going to be true. So probability that neither card is a diamond, neither first or second card is a diamond, right? Because the and means that they both have to be true. All right, so that is our answer, and that is it for probability and combinatorics, one of the topics in precalculus. Right, this is it for this video. Be sure to tune in for next time. We continue looking at more precalculus topics, more precalculus units. I'll see you then.